All right, so in that last video, we played this terrible little game of receiving one of these terrible non-deterministic machines and then slowly trying to manipulate this thing until we actually achieved a really nice equivalent deterministic machine. That is, we take this thing on the left that's got all this terrible structure and all these weird things that are happening, and we try to untangle it until we have something that no longer has these weirdo splits as well as these free ride passes. What we ended up seeing is we kind of started with where this whole process began, in that really the little machine on the left can either start at S0 or S2, and then we saw where those nodes went to, and then from those nodes we saw where those things went to, and eventually we ended up with this nice little system that had 6 states, and we're like, hooray, that's awesome. That built exactly what we were wanting to see. There is a little bit more method to the madness that at least I want to make you aware of, in that this is all part of a much grander theory, in that if you give me your favorite non-deterministic machine, so I don't care, 10 billion nodes, each of which are going to have 10 billion zeros that are going to go to 10 billion other nodes, and you quickly see how awful this thing is going to become. Even if you start with something as terrible and hellacious as that particular object is, you always are going to have an ability to convert this thing into something that's actually deterministic. And that's really cool, in that sometimes those non-deterministic ones are going to be easier to actually design, in that you have a little bit more freedom, you have more tools at your disposal. But sometimes the outcome is not going to be so great because you have this kind of weird clunky thing that's got all these zeros and free passes and all those things. So what we're going to say is that even if you have one of those objects, you can always convert it into something that's a little bit nicer. So it's going to be one of these deterministic objects. And what we have is we actually have a pretty nice constructive approach on how to make this transition. It gets a little bit unruly in terms of notation, so I'm just going to just chat about it with this last example and then say this is really how the whole process works, but if you want to dig into the terrible notation, that you can do on your own. Okay, so what we started with was this little machine that happened to have 3 overall states. What ends up happening is that the deterministic one that we're going to try to build is going to have these little states that are going to be achieved by grabbing a couple of those little entries. And those states are essentially viewed as, where could I be after, 2 or 3 moves? I could be at state S0 or S2, so I'm going to lump those together. And that actually was kind of how we started the last one up too, in that we're like, okay, well, starting this machine is really like starting either at S0 or S2, because I can use the free pass right from the get-go and split it into 2, so I might as well just view that as my starting node. So that's going to be a little collection of 2 of those states, and if I wanted to think about all of the possible connections of those little states, I'm actually going to have 8 of them. So the idea is that I can grab the single S0, I can grab the single S1, the single S2, I can go S0, S1, S0, S2, and finally S1, S2. I can do the triple as well as the empty one. So I end up having 8 of these possible little states that I begin with. It may not be the most efficient machine, but at least it gives me something that I start with. At some point in time, I begin scaling things back and trying to trim things up and kind of moving and shaking all of those little things together. So what happens there is that gives me my kind of initial groundwork, is that I have the little 8 states. Now what I got to do is go state by state, trying to see where they're all going to be connected to. So you basically grab a state and you think, what's going to happen with an input of a 1? What's going to happen with an input of a 0? So you ask that question for all 8 of them, which is automatically going to connect these things together with all of these little arcs. What you're going to see is basically the one that we built last time is going to live in the inside of that thing after you trim up a little bit of the fat. But that at least gives you a constructive approach of, you can always build up all of the states, go state by state, connecting all of the arcs by identifying what's going to happen under a 0 or a 1. So if you take this initial one, this 0, 2, that was where we started last time. So with an input of a 1, we know that S0 goes to S1 and S2 dies with a 1. So this state only has the potential to go to the singleton S1 with an input of a 1. And if with an input of a 0, the S0 can go back to S0, and the S2 could actually go to S0 or S2, so it's going to loop back on itself. So you run that thing by going through each of those little things and you get this terrible little structure. And then what ends up happening is that if you strip away all the terrible little horrible gunk that I just added to this picture, and if you stare at this picture long enough, you actually realize that some of these particular states have no arrows going in on them. Namely, these top two are never going to actually be achieved. So the input arrow goes to S0, S2, and you're never going to get to one of those top two things because there's no arrows pointing in on them. So if you snip those two things off, you end up with this little machine that has 6 states. And if you untangle it and retwist it a little bit, you end up seeing the exact same machine that we saw before. So there is a little bit more method to the madness if you would like there to be, in that you can build out this massive machine with all of the little arrows. So we had initially this machine with 3 states. So you're going to build 8 little states. Each of those things are going to have 2 arrows coming out of them. And then you can stare at that thing and then throw away all of the states that don't have any arrows pointed inward. If you want to try to untangle it and make it look a little bit nicer so that there's no crisscrossing, then you can kind of push it into that little final bit as well. So it takes a little bit of creativity to kind of see the kind of nice representation or the nice drawing for it, but I should at least allude to the fact that there are kind of these slightly more structured approaches to building these, and that you can just kind of let it loose and just being like, okay, blast it with as many states as you need, identify where all of those things have possible connections to, and then sew it all back together afterwards.